Alright, let's look at an example for finding surface areas. Alright, so let's say we have a cone whose equation is 2z squared is equal to x squared plus y squared. So it's a cone and going through the origin, and which looks kind of like that. Alright, then we want to find the portion of the cone, find the area of the portion of the cone over the region bounded by x-axis. Right, so that will be x-axis here. Right, and also y equals x over square root of 3. So it's just a straight line, so on the xy plane, and so I guess it's gonna look kind of like that. Right, and by the way, since the slope is 1 over square root of 3, which means that this angle right here is going to be 30 degrees or pi over 6. So maybe I'll indicate that. The angle here is going to be pi over 6. Right? Then also inside the circle, x squared plus y squared equals 4. Right? So let's look at the here. Let's see, I'm gonna use, maybe I'll just use blue. So radius is 2. Right, so let's look at that. Kind of like that, right? And in this case, I'm gonna just look at the region. You could actually include the region behind it, but I'm gonna just do this part right here. Right, so this is the region on the xy plane. Let's just use this pie-shaped region right here. So I'm just coloring it right there. Right. So you can see that if you go straight up there and go straight up there, and you can kind of visualize the region here. So this is the portion of the cone that we are interested. Let's see if I can draw this very well. So let's see. I'm gonna just use this green shape, green color here. Right. So this is the area, the region we are interested in. Right there. All right. So first, we're gonna have to find the secant and gamma. So let's try to find that. Right, so in order to find the secant and gamma, before that, I'm going to write this guy as, let's see, I'm going to put x squared and y squared over to the other side. So by subtracting x squared and y squared, we have 2z squared minus x squared minus y squared is equal to 0. Right, so we can call this guy right here, call this guy f of x comma y comma z. Right, then we can find the gradient there. So let's go ahead and find a gradient. So gradient of f is equal to, right, let's see, partial with respect to x would be negative 2x. Partial with respect to y would be negative 2y. Partial with respect to x would be, z would be 4z. Right? So remember that in order to find the secant and gamma, we would have to do, right? So secant of gamma is equal to, let's see, we take the magnitude of the gradient and divide it by partial, let's see, partial of f with respect to z, right? Right, actually, so secant of gamma, we would like to be positive, so make sure that it's positive here. So just take the absolute value of every one. Right? So in this case, on numerator is going to be negative 2 squared, so it's negative 2x squared, so it's going to 4x squared plus 4y squared plus 16z squared, right? Divided by partial with respect to z is 4z, so it's let's see, so it's 4z. Alright. Oops. Alright, then try to simplify as much as possible. Since we know that here, this guy right here is really the same thing as 4 times x squared plus y squared. But x squared plus y squared is the same thing as 2z squared, so this is going to be 4 times 2z, so it's 8z squared. Right? So this can be simplified too. So I guess we have to take the absolute value here. Right? So it's 8 plus 16, so it's 24. And a z squared, so I can pull that out. And you have 4 absolute value of z, so we can just cancel those. So we end up getting, let's see, 24 z is same thing as, let's see, 24 is 4 times 6, so 2 square root of 6 over 4. So we can cancel 2 and 4. So we get square root of 6 over 2, right? So that's the secant of gamma value, right? Then all you really have to do is, right, so we want to find the area that we're interested in. So this is the area right there, right, is equal to integral over this pie-shaped region. I'm going to call it R, and oops. And then you have square root of 6 over 2 dx dy, right? Then we just take out the square root of 6 over 2, then double integral over region of R dx dy, right? But here, this is just going to be the area of region R. So this is going to be just a square root of 6 over 2 times, right, area of this, let's see, radius is 2. So whole circle is going to have the area of pi r squared, right, but this is only 30 degrees, so 30 degrees is 1/12 of 360. So it's going to be, let's see, divided by 12. Alright, so we can cancel, let's see, so that's 4, so that's going to be 3 there. So this is going to be square root of 6. So pi square root of 6 over 6. So it's going to be pi over square root of 6. Right? So this is the area of this portion right here. Right? So when secant of gamma comes out to be a constant, all you have to do is find the area of the projection region. So this is going to be the region on the xy plane times whatever the secant of gamma value. Alright, secant of gamma happens to be a function, then you would have to go ahead and evaluate the double integral. But if it comes out to be a constant, all you have to do is secant of gamma value, which is, if it's a constant, times the area of the region of the projection. Alright, that's it. I hope that this was clear.